Skywarn training for the 2025-2026 winter season. First off, I always like to go over which office covers different people in North Carolina. The Raleigh office covers 31 counties of North Carolina. There are 2 other offices that are located in North Carolina itself, one in Newport, North Carolina, and also one in Wilmington, North Carolina. And then you can see that there are also offices in Morristown, Tennessee, Greenville, Spartanburg, South Carolina, Roanoke, Virginia, and Wakefield, Virginia, that end up covering portions of the state of North Carolina. So we are covered by a combination of 7 different offices. So why have a winter Skywarn presentation? The mission of the National Weather Service is to protect life and property, and winter storms certainly threaten life and property. For many locations in our region, winter impacts are relatively rare. Also, winter impacts are generally broad, while summer impacts are generally more localized in nature. So here's an outline of what I'll be going over during the presentation, going over winter hazards, how much snow we normally receive, what the difference is between an HWO, watch advisory and warning, some other product definitions, kind of some miscellaneous things, talk about snow and ice forecasts, and then what it is that we would like to receive from you in reports. So starting off with winter hazards. Our primary winter hazards that we would have here are heavy snow, ice, and cold outbreaks. Certainly on the left-hand side, you can end up seeing how much the ice was weighing down the trees. That is my manager's office and his house, with the trees just being weighted down from the ice. On the right-hand side is a pretty famous picture looking at US 70 on Glenwood Avenue near the Raleigh-Durham Airport. I believe this picture was taken back in 2014, and you can see it looks like something that would be out of an apocalypse movie. But that was just a 4-lane highway that was not very passable in that particular day. Snowfall statistics for Raleigh go back to 1887. When we take a look at climatology, it is looking over the last 30 years. And over the last 30 years, from 1991 to 2020, the normal seasonal snowfall in Raleigh has been 5.2 inches. The largest seasonal snowfall that we've had is 31.6 inches of snow, and that happened all the way back in 1892 and 1893. The largest monthly snowfall that we had was in January of 2000 with 25.8 inches. 20.3 of those inches ended up coming in January 24th and January 25th. So you can see that we had 2.4 inches of snowfall on January 24th with the 17.9 inches occurring on January 25th. And the highest snow depth, that is always measured at 12 Zulu, which is 7 a.m. Eastern Standard Time. And that highest snow depth was 20 inches on January 26th. Greensboro is another one of our long-term climate sites. Their records began in 1903. The normal 30-year seasonal snowfall is 7.1 inches, and their largest seasonal snowfall occurred back in the winter of 1926 and 27 with 32.5 inches. Their largest monthly snowfall occurred in 1966. And again, their largest snowstorm and their largest one-day snowfall both occurred in March of 1927. Our other long-term climate site is Fayetteville. However, we do not have a long-term snowfall observer there, so we do not have records going back for Fayetteville like we do for Raleigh and Greensboro. I'm going to show you this slide again later on in the presentation, but I wanted to first off end up talking about what the difference is between sleet and freezing rain. Both of them require alternating layers of cold and warm air. And so freezing rain is when you have snow that melts, but the layer of cold air at the surface is too shallow for the raindrop to freeze in midair. So the rain doesn't actually freeze until it reaches the surface. The difference with sleet is that the snow again melts, but it falls into a thicker layer of cold air, and so it's able to completely refreeze in the air itself. So again, as you look at this graphic on the right-hand side, you can see that a sleet pellet bounces when it ends up hitting the ground, while the freezing rain just ends up freezing on contact. And I have a couple more slides to help visualize this. So again, snow is going to be a deep, cold layer, very little of which or none of which is above freezing. Sleet has a shallow warm layer and it has a thick enough cold layer at the surface that the precipitation is able to completely refreeze before hitting the ground. While freezing rain typically has a deeper warm layer and the cold layer at the surface is not thick enough to allow that precipitation to refreeze before it hits the ground. Finally, one other way to end up looking at this is courtesy of the Maryland Office of Preparedness and Response. The difference between sleet and freezing rain, sleet is kind of like the sprinkles that you could end up seeing on a donut where the sugar has frozen before it makes contact with the donut, as opposed to freezing rain where you have the glaze that ends up falling and it is not solidified before it hits the donut and it ends up freezing on contact. So I really like this as a visual to show the difference between what sleet and freezing rain look like. There's a conversation that one of our forecasters had with Corey Davis, who's an employee of the North Carolina State Climate Office last December. And over the records that he ended up taking a look at, he had a count of 168 winter events, specifically in Wake County since 1959. So what, about a 65-year period. And during that time period, there were only 36% of events that had only snow. There were another 15% of the events that were only ice, in this case, freezing rain or sleet. And then the other 48%, there's some rounding here, 99%, 48% of events had multiple precipitation types, whether there was cold rain, something frozen, something snow. So you can see that in Wake County in general, we normally have a mix of precipitation types. It's rare that we have just one type and that we're gonna know the entire time what's gonna fall. If we more specifically look at RDU International Airport, and we look since 1996, over approximately the last 30 years, again, you can see with this that only 28% of the days had just snow. Slightly more had only ice or sleet, 21%. But again, 50% of the days ended up having multiple precipitation types. So again, at least half the time, we have multiple precipitation types. And so that can make it extremely difficult for us to determine exactly what precipitation type is going to happen and when. Some all-time cold temperature statistics for Raleigh. The coldest low temperature ever recorded in Raleigh was 9 degrees below 0 Fahrenheit. This occurred on January 21st, 1985. The high temperature that day only made it up to 7 degrees. The coldest high temperature was all the way back in 1899 for Raleigh, and the low temperature that day was 4 degrees. If we look at Greensboro, the coldest recorded low temperature, again, I believe those records go back to 1903, was -8, also in 1985, and they warmed all the way up to 21 degrees that day. And then there have been 2 separate times that the high temperature made it to 13 degrees. That was one way to ring in the new year of 1918, along with January 30th of 1966. And again, the low temperature those days were in the single digits. Finally, if we look at Fayetteville, their coldest low temperature all time was -1, again, January of 1985. You can see that they had a high temperature of 49 on the 21st and then only 21 degrees on the 22nd. The coldest high temperature was 18 degrees on December 30th, 1917, with a low temperature of 2 degrees. That being said, we haven't really had that much in the way of cold temperatures across our area recently. I will end up touching on that in a couple of slides, but taking a look over the last 5 years at some warm spells in Raleigh, if you take our daily high and low temperatures at RDU and you average them together for each day for the entire month of November, that average is 51.5 degrees. The record warmest November that we've had on record was 58.3 degrees, and that occurred in 1931 and 1985, with the lowest being 42.5 degrees in 1976. So you can see that you can end up having anywhere between 7 and 9 degree temperatures degrees temperature for what the range would end up being to that average temperature. If we take a look, we had our third warmest December on record in 2021. And again, you can see on the screen there what the normals were for December, the record warmth and the record cold. We did tie for the warmest daily January low temperature of 64 degrees on January 25th of 2024. If we take a look at February, had a couple records in February. We had the warmest high daily temperature ever, 85 degrees on February 23rd, 2023, and that certainly contributed to having the overall warmest February for the entire month in 2023. No particular records recently for the month of March in Raleigh. As we take a look in Greensboro, you can see the normal, the record warmth, and the record cold for each individual month. You can see that we had the second warmest December on record in 2021. And again, we tied for the warmest daily February high temperature at 81 degrees on February 23rd, 2024. And we had the second warmest February in 2023. Finally, if we end up going to Fayetteville, we had the second warmest December in 2021. And then again, 2023, tied for a warmest daily February temperature high of 85 degrees, tied for the warmest daily February temperature low of 66, and the fourth warmest February all time in 2023. Now, that being said, I did want to touch a little bit more on some cold temperatures. I got a lot of numbers on here, so let me explain what I'm doing with each row. If you look at the average daily high for each of those climate sites, Greensboro, Raleigh, and Fayetteville, Greensboro's coldest average daily high is 49 degrees. But what actually occurs in a given year, if you end up taking every year and what the coldest daily high temperatures that's recorded each year, and you average each of those, it's 28 degrees in Greensboro. So while we normally average out to a daily high of 49 degrees on the coldest day in Greensboro, what the actual lowest observed high temperature is 28 degrees in Greensboro. If we look in Raleigh, again, if you were to take normally somewhere around January 15th, and you average all of those daily lows, you come up with somewhere around 32 degrees in Raleigh. But on a given year, if you take what the lowest observed daily low was, whatever day that ended up being, that averaged out to about 12 degrees in Raleigh. And then finally, a cold snap that we ended up having back on December 24th, 2022. The high temperature in Fayetteville was 30 degrees that day, and the low was 15 degrees that day. And I can't remember which site was which, but I know that those temperatures, those low temperatures, it was the coldest day in 5 years at one of those sites. It was the coldest day in 10 years at one of those sites. It was the coldest day in 20 years at the last site. So that cold snap that we had 3 years ago, it had been many years since we had ended up having temperatures that cold. Moving on from some of those winter hazards, now talk a little bit more about how much snow we typically see. So many of these images are courtesy of the North Carolina State Climate Office. So this is taking a look. Again, our climate period is considered to be 1991 to 2020. And this is looking at our normal annual snowfall across the state as a whole. And as it says at the bottom, this is a broad scale climatology, which does not include smaller areas with maximum and minimum snowfalls. Certainly there are individual mountain peaks that are getting more than 24 inches, but this is smoothing that out. We aren't trying to pick out all the individual maximum and minimums. This was a map done by Eric Webb at Weber Weather on Twitter or X. He generated this data from many sources that you can see on the bottom left: CocoRez, Cooperative Observer Data, North Carolina State Climate Office, and others. And it ends up showing for different thresholds of snow amounts or freezing rain amounts when those storms end up occurring. So when it comes to any sort of snow occurring, at least over an inch of snow, that normally ends up having its maximum sometime in the second half of January. However, if you look at those blue colors, you can end up seeing that the peak for each of those colors is actually closer to the middle of February. So any amount of snow in that minor accumulation normally peaks in the second half of January, while the higher snow amounts typically peak in the middle of February. A lot of people talk about a rule of thumb being that there is a snow to liquid ratio of 10 to 1, with 10 inches of snow equaling 1 inch of water. And the image in the bottom right ends up showing the frequency of those different ratios being measured. So 10 to 1 is the most frequently measured ratio across our forecast area. There are certainly times that that is not the case. If you were to look to the left of that, where you might have something where it's a 5 to 1 snow to liquid ratio, that's going to be a very wet and slushy snow, because if it was a 1 to 1 ratio, that's essentially all liquid rain. So 5 to 1, 7 to 1, that's going to kind of be heavy, thicker snow. If you go to something higher than 10 to 1, if you're getting to a 15 to 1 or a 20 to 1 ratio, that's going to be a lot of light, fluffy snow that is not as dense with liquid. And that map image in the upper right is showing what the average ratios are. So the farther south and west you end up going, the lower that snow to liquid ratio is, the heavier and thicker the snow is. If you go farther to the north and east, you have a lighter and fluffier snow in a relative sense. Now this map is even older. I haven't seen one updated with new data going through 2010 or 2020. But this is showing the average snow to liquid ratio from 1971 to 2000. And so you can end up seeing that in the Rocky Mountains, they typically average higher snow to liquid ratios there. And certainly around the Great Lakes, there are higher snow to liquid ratio rates as well. I know that there are times around the Great Lakes that the ratio can end up being 20 to 1 or even 30 to 1 occurring with this. So there was one time at one of my previous offices that I ended up measuring ½ an inch of snow, but the liquid of the snow was less than 1/100th of an inch. So you can just imagine how light and fluffy that snow is. Taking a look at the snowfall statistics for Raleigh and Greensboro, again, we don't have a long-term set of numbers for Fayetteville. Again, the average seasonal snowfall is 5.2 inches for Raleigh and 7.1 inches for Greensboro. And you can see that for each one of the months, Greensboro typically has a little bit more snow than Raleigh does. November's pretty even. That's probably, what, 1/10 of an inch. So there isn't a huge difference in any one of the particular months. But for each month, Greensboro typically ends up having a bit more snow than Raleigh does. Again, some more images courtesy of the North Carolina State Climate Office. This is the last time that all these locations ended up receiving at least 1 inch of snow. And the color coding is based on the year that it occurred. So that dark blue, kind of a purple, is showing that nearly the entire state ended up having at least one event last winter where at least 1 inch of snow was received. So for much of the state, that was between February 19th and 20th. You can see if you go down by Charlotte, it's been a little bit closer to 2022, since those locations have ended up having 1 inch of snow. If you want to look back at the last 6-inch snow event, again, those blues are something that's occurred in the last 5 years, so up by the Outer Banks actually, and then much of the western third of the state. If you're looking in central North Carolina, you can see that it's been several years since that happened. The green, 2018, maybe earlier in the decade. You can see if you were to go down to Wilmington, it's all the way back to an event back in December of 1989, since they ended up having a 6-inch snowfall event. And finally, if we end up looking back at a 12-inch snow event, there's a very small piece of eastern North Carolina that the State Climate Office isn't sure if they've ended up having a 1 foot snow event out by Cape Hatteras. That was January 22nd, 23rd of 2003. Locally for much of Wake County, it was either the January 24th and 25th, 2000 snowstorm, or the January 2nd and 3rd, 2002 snowstorm. Certainly, as you go farther west, you end up getting the greens, the blues, which means that those events have occurred more recently. Another image put together by Eric Webb of Weber Weather, taking a look at the typical freezing rain events per year from 1992 to 2023. You can see if you go to our southern tip of Sampson County, that area averages about 3/4 of an event per year. So they normally don't have a freezing rain event every year. The peak is actually out in the Triad, out in Forsyth, Guilford, Davidson counties, where they're averaging between 2 and 2.5 freezing rain events per year. And again, typically with the way our weather ends up setting up, that is obviously a favorite area for freezing rain. And we'll get a little bit more into the details for why that is a little bit later on. All right, I got a lot going on this side, so let me explain what all the different lines are. The records for Raleigh go back to 1887, so that blue line is showing how much snow occurred each particular winter season. What I ended up doing with the red line is I'm showing a running 30-year average. So again, at this point, that climatology is around 5 inches. There's also a 10-year, which ends up going up and down a bit more. That should end up reacting a little bit more to individual seasonal snowfall. And then I also drew in yellow a line showing what the 1991 to 2020 climatology is all the way across. Those 5 heaviest snowfall seasons are in the upper right-hand corner, so you can see 26 years ago, 25.8 inches of snow was the 5th highest snowfall that we've had. But the real reason that I wanted to show you the graphic like this is that I wanted to show you how often we're within 2 inches of our climatology. And again, I'm using that 5-inch snowfall of climatology, which I realize that climate number has changed over the years. But I want to show you it's very rare that we're getting right around 5 inches of snow. Even if we were to make it a window of 3 to 7 inches, that's what I mean by within 2 inches of climatology. Only 17 years in this period going back to 1887 have had, there have only been 17 years within 2 inches of that climatology. So if we say that the average snowfall is 5 inches, very rarely are we getting 5 inches of snow. There are plenty of times that we're getting 10 or 15 inches of snow, and plenty of years that we aren't receiving any snow. So it's pretty rare to have an average year. And for this, I wanted to show how much snowfall we end up getting. So if you were to say that we had 4.6 inches of snow for a year, I would just count that on this chart as 4 inches of snow. And so it's interesting to see that the most frequent amount of snow that we end up getting is 0. And really what that means is not even necessarily 0 inches itself, but less than a full inch of snow. On this plot, 0.8 inches of snow does not round up to 1. It would go down to 0. So we've had 24 years where there was less than an inch of snowfall. We had 9 years where there were 1 to 2 inches of snow. And then the next most common amount was 2 to 3 inches of snow with, 16 or 17 occurrences. There were also 23 seasons with more than 13 inches of snow. But again, if you were to just take the 1 digit of snowfall that occurred in Raleigh, 0 is the most frequent occurrence. Here's the same type of plot for Greensboro, higher numbers overall, and you can end up seeing that, it was 21 years within 2 inches of climatology. Now, the climatology did start about 15 years later, so this is saying that within about 120 years, that 21 years were within that climatology of 7 inches of snow. That still means that if they're 21 years within 2 inches of the climatology of 5 to 9 inches, that's still 100 years that we have less than 5 inches or more than 9 inches. So again, it is rare for us to have an average year overall. And again, if we were to just take the ones digit of how much snow ended up falling, 0 is the most frequent occurrence. I think it's interesting that for Greensboro, the next highest number is 8 inches. They jump all the way that high, so over the average. And here there were 18 seasons of snow where more than 16 inches occurred. Now we're going to talk about what an HWO is, a watch, an advisory, and a warning. So we have 3 levels of notification. We have a hazardous weather outlook, watches, and warnings. A hazardous weather outlook generally discusses storms and events several days in advance to alert the public for potential and allows for early planning and preparations. And this isn't just for wintertime, this is for summertime and any other type of weather, tropical, for example. And a hazardous weather outlook is typically issued when we have about 30% confidence that we may need to issue a warning at any time during our 7-day forecast period. A watch is issued for heightened potential of warning criteria event, whether that's a winter storm, whether that's a blizzard, whether that's extreme cold. And a watch is typically issued with at least 50% confidence of warning criteria. And finally, warnings are issued when there is a high probability of warning criteria, winter storm, blizzard, extreme cold, or the warning criteria is already occurring. And this is supposed to be issued with approximately 80% confidence of warning criteria. Now, I haven't mentioned advisories yet. Advisories are somewhere less than a warning. There is a high probability of an event that will produce conditions that can be a nuisance but are not considered to be life-threatening. And this is typically issued with 80% confidence of advisory criteria. And the advisory criteria is lower than a warning. So warning and advisories are both issued with approximately 80% confidence. It's just that the warning criteria is of a greater magnitude than the advisory criteria. But we don't want you to think of a watch to an advisory as a downgrade. Although warning criteria is higher than advisory criteria, the issuance of an advisory still means there's high confidence, at least 80%, that there are going to be impacts that are important for you to know about. Marshall Shepard has shared this example from Brad Panovich, a Charlotte television meteorologist, talking about the difference between watches and warnings. The analogy was that the watch means that we think that we have the ingredients that we need to produce something, and that the warning means that those ingredients have come together to actually produce the item that we're worried about. So if you take a look at the cupcake watch, you have the ingredients to form a cupcake. You have sugar and flour and butter and eggs, but you don't actually have a cupcake at this point. You just have the necessary ingredients for one to form. The cupcake warning itself is not issued until you have very high confidence that a cupcake is going to be formed or the cupcake itself has come to fruition. So similarly, when we issue a winter storm watch, that's because we think that the ingredients are there for a winter storm to occur. But the warning is when we actually think that it is going to occur or it is currently in progress. And again, just putting these differences for a winter storm watch, a winter storm warning, and a winter weather advisory on the same graphic. Now I want to go over some other product definitions. So what is our winter storm warning criteria? For snow, it's if we expect to have 3 inches of snow in 12 hours or 4 inches of snow in 24 hours. We can also issue a winter storm warning. If we're issuing it just because of ice, that requires at least 1/4 of an inch of ice accumulation. That would be from freezing rain specifically. A winter storm watch is when we're expecting a 50% potential for winter storm warning criteria in the near future. And again, that could be the 3 inches of snow in 12 hours for snow, or a 50% chance for 1/4 of an inch of freezing rain accumulation. Again, advisories are for lower events, for lower criteria events that would still be nuisance or the potential to cause hazards. So for snow, that would be 1 inch of snow in 12 hours or a mix of accumulating snow and ice, because we're supposed to issue a winter weather advisory for ice if we expect any accumulation of freezing rain. So if we have any freezing rain that occurs for more than 30 minutes or so, we should be issuing a winter weather advisory for that, because any ice can make roadways hazardous. Now, I didn't update these graphics for the events that we ended up having last year. I generated these graphics on December 3rd, 2024, and this is taking a look at our 31 county area and over a 20-year period, on average, how many warnings we've issued each year and how many advisories we've issued each year. So on the left-hand side, you can see that Sampson County has averaged 2.55 advisories between 2005 and 2024. And you can see, again, out in the triad, that those are where we end up having our highest numbers of advisories, normally somewhere around 5 advisories on average per year. On the right-hand side, you can see the winter storm warnings. We don't issue those as much. That lowest blue color is showing locations that have had somewhere between 6/10 and 9/10 of a warning per year. Of course, I understand I can't average 9/10 of a warning, but again, this is averaging out over approximately 20 years. And again, if we're looking at Forsyth, Guilford, and Person counties, those are our counties that typically have the most warnings, and they're averaging about a warning and a half per year. Now, if you look over the same time periods, it's slightly different from a day's perspective. But taking a look at the winter weather advisories on the left and the winter storm warnings on the right, you can see that if we're averaging 2, 3, 4, 5 advisories per year in central North Carolina, you can see that there are portions in the North Carolina mountains that are averaging a dozen advisories per year. And you can go out to the coastline and see that they're averaging 0.2 advisories per year, 0.45. So they might issue an advisory every other year on average. And if you take a look at those warnings, again, there are some counties that are averaging 4 to 5 warnings per year, while for our area, it's normally about 1 warning per year that is issued. Some more winter weather criteria. I have wind chill warning and wind chill advisories crossed out because we don't issue wind chill warnings and wind chill advisories anymore. I believe this is the second winter that we have switched to extreme cold warnings and cold weather advisories. And this is related to the wind chills themselves, which is also known as the apparent temperature, which is also known as the feels like temperature, which is taking the air temperature and accounting for the fact that it feels lower when you add the wind in. Another change to the extreme cold warning and the cold weather advisory is that it does not require the winds to be of a specific speed. So in that sense, it can just be cold weather without any wind. The wind chill warning and wind chill advisory required there to be at least a 3-mile-an-hour wind or a 5-mile-an-hour wind. That is no longer a requirement. And we do have 2 different thresholds across the forecast area. I'll show you that map on the next slide. We also have high wind warnings, which is when we're expecting a sustained wind of at least 40 miles an hour to last for at least 1 hour. It is very rare for that to happen around here. What is much more common for us to issue a high wind warning is when we expect a gust of at least 58 miles an hour. And if 58 miles an hour sounds familiar, that is also the criteria for a severe thunderstorm warning. And if 58 miles an hour seems like an odd number itself, 58 miles an hour is the same as 50 knots, which is 50 nautical miles per hour. For a wind advisory, that's when we expect sustained winds of 30 to 39 miles an hour for at least 1 hour. And again, it is very rare for us to have that in central North Carolina. It is much more typical that we end up having a gust of at least 45 miles an hour. So again, these cold weather products are based on apparent temperatures and no longer have a wind requirement. So you can see many offices have 1 or 2 different thresholds. Again, Blacksboro to our northwest, Wakefield to our northeast, Moorhead to the east, Wilmington to the south and southeast, Greenville, Spartanburg to our southwest. And the extreme cold warning on the right-hand side, I will end up saying that we have not issued any products yet, but we are looking at the potential that we will need to issue a cold weather advisory that may be issued on our day shift today. And the threat time that we are taking a look at is going to be tomorrow night, December 14th into December 15th itself. So what is the science behind wind chill? If you look at the left-hand side, when there isn't any wind and you have an average temperature of the human body, 98.6 degrees, under calm conditions, the body radiates heat and it is able to create a layer of warmth between our skin and the cold surroundings. However, if it's windy out, what ends up happening is the wind blows that layer of warmth away from our skin. And so that ends up speeding up the heat loss by whisking away the warmth from our skin. And so that's when you can end up having hypothermia end up developing, when your body temperature drops by multiple degrees. So that's the reason that a calm night that you don't have as great of a wind chill, because that insulating layer remains around your body. Blizzard warnings. I'll just jump to the bottom bullet and say that the Raleigh office has never issued a blizzard warning. But blizzard warnings are not dependent on snowfall accumulation. They have 3 requirements: frequent gusts to 35 miles an hour or more of wind, snow, whether it's blowing or falling, reducing the visibility to a quarter mile or less, and that it lasts for at least 3 hours. And it is pretty rare for us to have the visibility that low and the frequent gusts and have all of that going on for 3 hours or more. So in that sense, I really shouldn't show you a picture with a car covered by snow, because again, we could have 2 inches of snow and meet the blizzard warning criteria, because it doesn't matter how much snow falls, it just matters that you have the frequent gusts and the low visibility for a certain amount of time. All right, I want to go over a few miscellaneous items. What are some major systems that provide us with wintry precipitation in the Raleigh forecast area? I'll go over each one of these separately. An Alberta clipper is named for the Canadian province, Alberta. Since the system develops over land, there's limited moisture, and that may result in only light snowfall, even if the coverage is widespread, as that low ends up moving across the Great Lakes and to our north. It'll end up bringing in cold air behind it. So even if there isn't a lot of moisture, you might end up getting a lot of widespread coverage of light snow. And again, another graphic that was put together by the National Weather Service, weather.gov, a narrow band of dry but significant snow. Nor'easters kind of have 2 different reasons for their names. They're named because the storms are moving towards the northeast, but also northeast winds are experienced on the leading edge of a storm, because with low pressure, the winds move counterclockwise or cyclonic. And so we always describe the wind as the direction that it is coming from. So when we refer to a northeast wind, that means the wind is moving from the northeast towards the southwest. And those typically form and move up along the East Coast. And while many nor'easters can pass east of the forecast area, not all of them do. We certainly ended up getting a good amount of snow in 1993 as that particular low pressure system ended up moving from the Gulf up towards Georgia and then up into the Northeast. And again, another specific weather.gov graphic. I'll leave this up on the screen for a second for you to read. Cold air damming is a phenomenon that we have occur a lot more in North Carolina, and this can end up leading to us having mixed precipitation events. So what ends up happening is, if you were to pretend that these are the Appalachian Mountains, you have cold air that is moving from the northeast to the southwest. It is on the east side of the mountains. What ends up happening is warm air will end up moving in from the east, and if cold air sinks and warm air rises, what happens is the warm air will rise up and over the cold air. So we have cold air at the very highest levels of the atmosphere. Then we have a layer of warm air in between, and then back down towards the surface, we have cold. So if we have cold, warm, and cold air, that's going to cause us to have some mixed precipitation types again. So again, I'm bringing back this graphic that I know that I already showed you. And so again, I just wanted to emphasize that with cold air damming and figuring out the precipitation types, it's very dependent on how thick the warm layer of air is to determine if we're going to have rain, freezing rain, sleet, or if you don't have any of the warm air layer, then you could just end up having snow. So the difficulty that we end up having as forecasters is determining the thickness of both the warm and the cold air. So again, if you're by the mountains, maybe that warm air doesn't make it all the way there. And so at the mountains yourself, you just have snow. Then if you have the cool air and the cold dense air or the warm air, it's a matter of trying to figure out just how thick the warm air is, how thick the cool air is, and then where those lines move, the snow mix line and the rain mix line, because that warm air rises over the cold dome. And we can have times that we are off with that snow mix line and the rain mix line by 10 or 20 miles, and we feel that we had a pretty good forecast. At the same time, if you're 10 or 20 miles east of that line, you may end up with something much different than what you thought you were going to end up having. And so that is the difficulty with cold air damming events. Does wintertime lightning equal snow? I know that a lot of times people say, well, if you hear lightning in the wintertime, you'll have snow in the next 7 to 10 days. This was more research done by the State Climate Office. This was done by Corey Davis, and there's a link to where he posted it on his blog back to that North Carolina State Climate Office blog back in December of 2013. He looked at all lightning reports between December and March in Asheville, Charlotte, Greensboro, Raleigh, Wilmington, and Hatteras. And from the late 1940s to 2012, there had been 642 days where thunderstorms occurred, but snow was only observed 13% of the time in a 7 to 10 day window after that. So in that sense, only 13% of the time did wintertime lightning equal snow at those sites. This is the winter outlook issued by the Climate Prediction Center. We are under a La Nina pattern, which typically ends up meaning warmer than normal temperatures and drier than normal temperatures. So on the left-hand side, this was their seasonal temperature outlook that they issued on November 20th for December, January, and February of this winter. And you can see that they are leaning towards above normal temperatures. This doesn't say anything about how much warmer than normal, just that they're leaning towards above normal temperatures across North Carolina. If you look on the right-hand side of the image for the seasonal precipitation outlook for December, January, and February, that ends up meaning that they are looking towards below normal precipitation. Now, something that I want to point out, I already talked in this presentation about how much snow we ended up getting back in January of 2000, and that was a La Nina year. So we had one of our snowiest seasons of snow ever in a La Nina year when we were supposed to have above normal temperatures and below normal precipitation. So just because the seasonal prediction is warmer than normal and drier than normal doesn't mean that we can't still get snow. And specifically, this seasonal precipitation outlook is for the amount of liquid that falls, so rain and snow. This is not specifically expecting this precipitation as rain or as snow. It's just any precipitation in general. La Nina is typically associated with a weaker and northward shifted jet stream, which puts our state south of the prevailing storm track to make us generally warm and dry. I don't quite like the color scales as much on this, but again, this is taking several La Nina years and seeing what actually occurred in those years. And so on the left image, the yellow and brown and red colors are showing warmer than normal temperatures. On the right-hand image, the right is showing drier than normal in the red. So you can see around the Great Lakes that they have the blue and green colors, which are signaling above normal precipitation anomalies, but you can see that across much of North Carolina, those orange and red, those warmer colors, indicating below normal precipitation anomalies. So how is it that you can end up measuring snowfall? You don't need to officially have a 24-inch by 24-inch whiteboard, but that's the sort of thing we end up using a yardstick, flags, so you can end up seeing where your board is once it's covered in snow. You're going to want to find an open area that's away from tall objects, but is sheltered from the wind blowing everything away. We do end up saying that you normally want to have your board at least twice as far away as any obstruction near it. So if you were to have a 20-foot tall house, you would want to make sure that your snowboard is at least 40 feet away from the house. You want to get it set up before the snow begins. You want to make sure that the board is outside and is acclimated to the temperature. So you don't have to have a flag, but that's going to help you find your board later on. You want to measure your total to the nearest 1/10 of an inch, and it's good for you to measure once daily at the same time. We typically end up having our cooperative observers and our CocoRa's observers trying to give us their report around 12 Zulu, which is 7 a.m. Eastern Standard Time or 8 a.m. Eastern Daily Time. So after you're done measuring, you want to place the board back on top of that snow. Then again, if the snow stops, you want to measure as soon as the snow stops to make sure that you don't have any lower totals due to melting, settling, or drifting from the sun. And then weather.gov or social media is a great way for you to send us your reports. How is it that you measure ice? There are two ways to end up doing this. You need to tell us which way you ended up doing it because the numbers are slightly different if you measure on a flat surface or if you're measuring radially on a twig or a branch. And ice measurement should always be rounded to the nearest 1/10 of an inch. If you don't have at least a 1/10 of an inch, you can report that as a trace. All right, a little bit more about snow and ice forecasts, and finally what it is that we're hoping that you will report to us. So where can you find our snow and ice forecasts? If you go to our homepage, it's weather.gov/Raleigh, and then from there you could also type in /winter, or you can click on the winter weather icon. This is the type of page that you'll end up coming to. So this is an example that I took from last year where the expected snowfall was the large image on the left-hand side showing that to the northeast of Mount Airy is where they were expecting some slight snow accumulation. And then on the right-hand side, you have the high end and the low end amount of what is forecast. The high end says that there's a 1 in 10 chance of having snowfall at least that high. So on that particular day, in the next 3 days, there was the possibility of at least a 1/10 of an inch of snow getting into Winston-Salem and Greensboro. But on the low end, you could end up seeing that there wasn't anything shaded into the northwest of Mount Airy. And in that In that case, there is at least a 90% chance that you have higher than 0 snowfall. And you can get that by clicking on that green tab, the probabilistic snowfall forecasts. And again, just showing you this image a little bit bigger again on the left-hand side to the northwest of Mount Airy where there was the potential, the official snowfall forecast was calling for at least 1/10 of an inch of snow. You can also end up looking at the percent chances that the snow amounts will be greater than something. So in this case, we consider measurable snowfall to be at least 1/10 of an inch of snow. And so on this particular day, there was a 17% chance that Winston-Salem was going to have at least 1/10 of an inch of snow, while there was only a 5% chance at Roxborough. However, Mount Airy ended up having at least a 50% chance of having measurable snow that day. You can mouse over each of those individual images, the 0.1 inch, 1 inch, 2, 4, 6, 8, 12, and 18, and the large image will change to what you've moused over. It's also possible for you to look up individual towns. There are hundreds of towns where you can end up getting this data for. It'll give you the values for that low end, expected amount and the high end, and then again what the percentages are for the 1/10 of an inch, 1 inch, 2 inch, 4 inch, 6, 8, 12, and 18 inches of snow. Again, that particular day, if we had zoomed out a bit more and we got to the mountains, you could see that Boone had at least a 30% chance of 1 inch of snow. And Beckley, West Virginia had at least a 65% chance of 1 inch of snow, while they only had a 4% chance in Beckley of at least 4 inches of snowfall. So these images are available on different scales. Finally, what is it that we want you to report? When you report your weather to us, please give your location, including your county, since there are duplicate town names in our forecast area, and the time that you took the observation. If you're giving us a snowfall observation, we want to receive the total amount of snow that you've received. If you freeze and drizzle or rain, there are 3 different things that we'd like to know. We'd like to know if there's any occurrence of freezing rain, because again, our winter weather advisory says that if we have any freezing rain occurring, that we want to make sure that we have an advisory out for that. So if you observe any freezing rain, we want to know about that. We also want to know if you reached at least 1/4 of an inch of ice, because that is our winter storm warning criteria. And then finally, whatever your total ice accumulation is once all precipitation has come to an end. We aren't going to issue any particular product if there is thunder or lightning associated with snow, sleet, or freezing rain, but we're going to kind of nerd out if that ends up happening. And also, if there is thunder or lightning occurring, that really means that we have a dynamic system that's going on. And so that gives us a heads up that we need to consider that things could be a little more potent than we were expecting. Even though the wind advisory criteria is 45 miles an hour, we'd like to know if the wind is at least 40 miles an hour near you, but specifically only if it's measured. Many people overestimate wind speeds when they're just looking at trees or branches. So we really don't need to get notified of the 40-mile-an-hour winds unless you have measured those wind speeds. Finally, how can you submit a report? You can email us at nws.raleigh@noaa.gov. You can also go on our Facebook page, our Twitter page, and end up giving us reports there. We always like to touch on our Skywarn amateur radio networks. So the Central Carolina Skywarn is one of 2 designated Skywarn programs to serve the Weather Service in Raleigh. Spotters with a ham radio license can make reports via the Central Carolina Skywarn net. The primary repeater is 145.210 with the backup at 146.88. Virginia Enzor is our emergency coordinator, and she or somebody else with the Central Carolina Skywarn will pass those reports along to us. Anybody can listen to Spotter Reports live streamed on www.broadcastify.com. You go to live audio, North Carolina Wake and Central Carolina Skywarn. And then Central Carolina Skywarn has their own Facebook page that is listed there. There is a test that occurs every Tuesday night at 9:15 p.m. on the 145.210 repeater. And again, that is live streamed over Broadcastify. Also want to talk about the Triad Skywarn, which is the other National Weather Service designated Skywarn program that serves the Raleigh office. Spotters with a ham radio license can make reports via the Triad Skywarn net at 147.255 megahertz on the Asheboro repeater, and John Hamilton is their emergency coordinator. And you can find more information available at triadskywarn.blogspot.com. Do you know that the National Weather Service uses COCORAS reports for river forecasts, flood warnings, and other snow reports? COCORAS stands for the Community of Collaborative Rain, Hail, and Snow Observations. So if you want to become part of the COCORAS team, you can join today at cocoras.org. That is not officially sponsored by the National Weather Service. However, we are very reliant on the data that COCORAS receives. And one final thing that I wanted to touch on is the MPING project, Meteorological Phenomenon Identification Near the Ground. You can let us know what precipitation type is happening at your location. This is a free app that is available through iTunes and Google Play. This is an image that I got from 10 years ago up in the Pittsburgh area, where the green is indicating liquid rain, but all of the pink is indicating freezing drizzle and freezing rain. So you can send in your results to us, what your precipitation types are, through the MPING app itself. And then you can use that app itself to see what reports other people have ended up sending in.